Okay, so that's me, no doubt. Good. Okay, then I can then start. So this is not my pen. Okay, so today this is a very important chapter. So today we will see quotient topology. So this is very conceptual and also very important topic. So you should be very careful throughout the lecture. So first of all, I define quotient map. Okay, so let X and Y be two topological space. So let P from X to Y be a surjective function. So a surjective continuous map. Okay, so it is surjective and as well as continuous. Now then we say T is a quotient map if it satisfies the following condition. So what condition? This condition is, so a set U is open in Y if and only if P inverse U is open in X. Okay, so last time I have seen so many students have some doubt about that what is P inverse U, though P is not a bijective map. So remember that here P is a function. Okay, but P may not be bijective. Then what is P inverse? So P inverse not a function, but P inverse U is a set. Okay, so it is not that P inverse of U. It is not like that. It is just a P inverse U. Okay, and it is a set. That's mean all the pre-image of the elements of Y, the collection of pre-images of the elements of U. Right, so this is a set, and this is just a notation that P inverse U. Okay, so I am not claiming that P is bijective, or I am not claiming that P inverse is a function. Okay, so that's when quotient map is looks like a homeomorphism, right? Now, what was the definition of homeomorphism? It was P is a bijective continuous map, right? And A set U is open in Y if and only P inverse U is open, right? But here the quotient map is we release the bijective here, right? So instead of bijective, we just need a surjective, but we need surjective. You remember that we need surjective. That is important. Okay. Now equivalently, we can also say that that's mean a P is a quotient map if that a set C is closed in Y if and only if P inverse C is closed in X. This is the equivalent condition. Why? Because we know that P inverse y minus c is x minus P inverse c, and P inverse similarly y minus u will be x minus P inverse y u. So therefore this is a equivalent condition. Okay. Now example. Now can you give me one quick example of a quotient map?
Identity map from X to X.
No, not bijective. That is a trivial one. Not those trivial. Just give any other example which is not too trivial.
Any open map.
Right. So that is one. So any open, better to write open continuous map.
But onto होनी चाहिए.
Aha. Good. Continuous surjective map. Surjective map is also a quotient map. Similarly, you can say that any closed map. So closed map. Map means generally we consider continuous. And surjective also. Surjective map is also a quotient map. Okay, so now these are we know. Now can you give one particular example of such open map which you know? Right. Another one is projection map. So we can take pi1 x cross 2 y 2 x. Say pi1 x y equal to x. Right, now this is, now why this is open map? Have you seen the proof why this is an open map? Do you remember? Because any basis element of x cross y is u cross v, and pi1 u, that basis element u cross v equal to u, which is open. So this is an open map, right? Because it sends basis element to open sets. So therefore it will send the any open set to a open set only. Right? So it is open map. It is open surjective continuous map. So pi1 is also a quotient map. Okay, so that's when we know that if you have any open map, surjective map, it is a quotient map, and even closed map is also a quotient map. Now what about the converse? Now if you have a quotient map, is it necessary it is also a open map or closed map? Obviously converse should not true. Now can you give one example? That quotient map but not closed map, quotient map but not open map. Can you give some example? Do you have any? So I can start with this one only. Now say pi1 r cross r to r. Okay, now we know that this is open map, so it is a quotient map. We know quotient map. Now we show that this is not a closed map. Why this is not a closed map? We
Sir, we
take
can take a hyperbola in R cross R and
exactly. We can take that xy where x, y equal to 1, right? And then this is obviously closed in R cross R, but pi1 of C, that will be R minus 0, which is not closed. Okay, so that is one example. Now we can see another example. Now before going to that example, I just want to define another set called saturated set. Now what is saturated set? Now let P x to y be a surjective continuous map. Just a surjective map also is fine. Okay. Now a set C, that means subset in X, is said to be saturated if C intersection P inverse any singleton equal to non-empty imply P inverse Y totally contained in C. So in other words, C is this is complete inverse of a set. Inverse of a set. Okay. So that's mean if you take for an example, okay, better to give one example. Uh, say f is a map say from R to R, say fx equal to say x square. Okay. Now if you take say 0 1 closed interval 0 1, then is it a saturated set?
नो।
Why?
2 की प्रीमेज नहीं आएगी इसके अंदर।
2 के प्रीमेश के तो साथ इंटरसेक्शन भी नहीं होगा। 2 के प्रीमेश तो यहाँ पे एम्प्टी हो जाएगा। You are very close. Just give. You should understand what is the meaning of saturated set. That's mean if this for some y, then वो जो set है totally contained हो जाएगा C में।
वन की
Sir, 1 and -1 have image.
Right.
So if
So it is not saturated. Not saturated. Why? Because 0 1 in intersection of P inverse of singleton 1, that is non-empty, but P inverse of 1 does not subset of 0 1 because this is 1 and -1, right? Now what about -1 comma 1 here? Is it a saturated set? Yes or no?
yes, sir,
Yes, because you can write it is as P inverse 0 1. Right, that's my F inverse. Okay, say this is P. So that's when in this case here it is saturated, though it is not surjective anyway. That is fine. How to take that? Then okay, we can take here 0 infinity. Then it will be surjective. Okay, better to write that. Okay, fine. So that's mean we have another definition of quotient map. Quotient map, another definition. So a continuous surjective map f from x to y is said to be a quotient map if image of each saturated open set is open, or you can write closed also. Okay, that's mean if you have a continuous surjective map and if image of not every open set, okay, if image of every open set is open, then that is fine, then it is also open map, and we know that in that case it is a quotient map. But we do not need to check all the open sets. If only the saturated open sets goes to open, right? If image of a saturated open set is open, then also we will say that it is a quotient map. Okay, ठीक है. तो इसका मतलब क्या है कि क्वोशिएंट मैप दिखाने के लिए हमें सारे के सारे ओपन सेट के इमेज ओपन सेट दिखाने की जरूरत नहीं है. होगा तो अच्छा है, नहीं होगा तब भी ठीक है, बट हमें ये दिखाना है कि image of each saturated open set is open. Okay, now we give another example. Now that is a good example. Now say P from 0 1 union say 2 3 to 0 2 defined by Px equal to x 0 less than equal to x less than equal to 1 equal to x minus 1, where 2 less than equal to 3 less than equal to x less than equal to 3. Okay, now this. Now tell me, is it a quotient map? So first of all, one, P is surjective or not? Yes or no? Surjective?
Yes, sir.
Yes, so P is surjective. Okay, it is surjective, one part is done. Now P is a open map. Is it a open map?
Yes.
Yes. Quickly give the answer. Yes or no?
Yes, sir.
Yes.
Mm.
So P, but why it is an open map? Okay, it is not
Image of
an
X,
open map. Why?
image of
Because that 0 1 is open. Why 0 1 is open? Because we have taken the subspace topology. Okay, So subspace of R. Now it can be written as say -1, 3/2 intersection X. Say this is your X. Right now this is open in R and X is your this set. So therefore this is open in X. Okay. So this is your open set. Now what is your P of this open set? 0, 1. Now this is again 0, 1 in where? In Y. What is Y? 0, 2. But this is not open in 0, 2. But P 0, 1 is not open in 0, 2. So therefore this is not an open set, open map. Is that clear to everyone? Yes.
Sir, explain once again.
ओके ए क्लियर हुआ है ए क्यों ओपन सेट है एक्स में सो व्हाट इज पी पी is a map from x to y. What is my x? X is my 0, 1 union 2, 3 and what is y? Y is my 0, 2. और टोपोलॉजी क्या है? सबस्पेस टोपोलॉजी in R. Similarly, subspace topology in R. ओके तो ये सबस्पेस टोपोलॉजी में 0, 1 जो क्लोज मतलब क्लोज्ड इंटरवल है ये ओपन सेट होगा इन x क्योंकि 0, 1 को हम लिख सकते हैं ओपन इंटरवल दिस इंटरसेक्शन x. Now we know that open interval -1, 3/2 is open in R. So therefore this intersection with x will be a open in x. But what is my image of 0, 1? Now image of 0, 1 will be 0, 1 by this map only. And this is subset of 0, 2. But this is not open in 0, 2. Why? Because as 1, so this is just 0, 1 and 1 is not an interior point. Okay. Is it fine?
Yes, sir.
Okay. Now it is surjective, but it is not open map. Now what about? Is it a closed map?
Yes, sir.
Now this is a closed map. Why? Because any closed set here, in fact in R, either a closed interval or a set, singleton set kind of set, right? Or some finite set. Okay. In this interval, right? It cannot be infinite actually. No, here it can be infinite as well, right? We can take interior anyway. So you can check here by of these two functions, this one and this one. If you take any closed sets, right? What are the possibility of any closed sets? Either it will be a closed interval, right? Or it can be infinite as well with the limit points. But anyway, limit points will be either contained in this one or this one. In any case, it will be the almost same sets, or if it goes by this map, then it is just a translation, right? So therefore it is also closed. So therefore P is closed. Okay. Now from this, can you say that P is a quotient map?
Yes, sir.
Yeah, yes, because it is surjective and closed. So P is quotient map. Is a quotient map. Okay. Now see at one thing. So P is a quotient map, but P is not sending one open set to an open set. So P is not sending this open set to a open set. Now the question is that 0, 1, this open set in X, is this a saturated open set? Because quotient says that it sends any saturated open sets to open sets. Right. What is the definition of quotient map? It sends saturated open sets to a open set. Okay. So any quotient map send a saturated open set to a open set. But here we have seen that P is not sending this open set to a open set. What does it mean? That's mean this open set should not be a saturated open set.
So for y is equal to 1, it is not.
Right. Now again the same problem with y equal to 1. Because 0, 1 intersection P inverse 1, that is singleton 1 only. That is non-empty. But what is P inverse 1? Now P inverse 1 will be two sets, whether 1 and 2, which is not contained in 0. So this is not a saturated open sets. Okay, so this is just one observation. Fine, now I hope you all understand what is actually a quotient map. Now we have quotient topology. So quotient map, quotient topology, and quotient space. These three are same, means just corresponding term. Okay. So I should write so quotient map, quotient space, and quotient topology. So these three are just corresponding terms. If you know one, then you will know the other two as well. Okay. So what is first of all quotient topology? So now let X be a topological space. And A is a set. Remember that A is a set. We are not saying that it is a topological space. Okay. And P x to A is a surjective function. Again, we are not saying that it is continuous. Why we cannot say P is continuous? Because A does not have any topology. So therefore you cannot say about the continuity of P. Right? Now A can be given a topology such that P is a quotient map. Given, you can say better to hai a unique topology. Unique topology such that P is a quotient map. How? Now how to define the open set of A? Now that is also trivial. Can you tell me how to define an open set in A?
Inverse U open.
Right, that's all. Now U is open in A if P inverse U is open in X. In this way, you can define U is open sets in A, and it is easy to verify that since that P inverse, that arbitrary union equal to this one, and also that so you can now easily know that actually, so P inverse of that MT equal to MT. Now since P is surjective X, now it is easy to say that it is a topology actually, and also P inverse intersection of pi equal to 1 to n uy. Okay, so this satisfies all the property. So that's mean finite intersection, arbitrary union, empty set, X, all are open in Y. So open in X. So this forms a topology. Okay, and by construction it is unique because there are only one. We are defining in this way only. Now A, okay, forms a topology. Now this topology is called the quotient topology. The quotient topology on A. Okay, and also A with the topology is said to be quotient space. Quotient space of X by the map P. Okay, so now quotient topology, quotient map, and quotient space, these three are clear to everyone? Any doubt? If you have any doubt, now you can ask. Because now we are going to the examples. Any doubt about regarding this term, these three terms? Yes. So we know quotient map, we know quotient space, we know quotient topology. So that's mean if you have a two topological space X and Y, and say P is a continuous surjective map such that U is open in Y if and only P inverse U is open in X, then P is said to be a quotient map, and Y, the topology in Y is said to be quotient topology, and Y is said to be a quotient space of X by the map P or by the quotient map P. Okay, any doubt?
Sir,
Hmm.
sir, ऊपर जो आपने define करा that a continuous open map is a quotient map if every saturated open set is mapped to saturated open set. So is this an if and only if condition?
यहाँ पे लिखा हूँ.
सर ऊपर saturated open set के पास.
अच्छा वो मैंने डिलीट कर दिया हूँ यहाँ पे. नहीं हाँ दोबारा बताओ एक्चुअली क्या था वो, मेरा क्वेश्चन क्या है?
Sir, you gave the equivalent definition that a continuous open map is a quotient map if every saturated open set is mapped to a saturated open set. So I want
No.
to ask.
Saturated open sets to a open set, not saturated.
Okay, so is the converse true? Means if every set
Okay,
is
okay.
this a
So
definition?
uh, what is the meaning of definition?
Okay, this is a definition. I thought it was a result. Okay.
No, no, no. So I gave you an alternate definition, right? So that's when it is a if and only
Okay,
condition.
okay, sir. Okay, thank
Sir, what are the guarantee this quotient space quotient topology is unique?
That is a good question. That is actually by the construction because you are taking only those open sets. That's when you are considering all the open sets actually, such that P inverse U is open. Whenever you have open, then P inverse U are open. Then those are all the possible collections of open sets. You are not taking any extra or anything else. You have a particular open sets and you are taking inverse image of all of those open sets and they forms a topology. That's it. So that will be unique only. So that is actually nothing to prove to prove the uniqueness. That is trivial by the construction.
Okay, sir.
Right. Now actually what we do now, given a topological space X, we will given a topological space X, we will give a quotient space. We will define some quotient space. Okay. Now that is a little bit tricky. Tricky in the sense that it is some kind of partition actually. So in terms of partition, we will define that. So it looks a little bit complicated, but you have to be careful about that. So just focus on that, then you will understand. If you lose your focus, then you definitely will not understand. And in minor, there will be definitely one or two questions from this. So that is my favorite chapter. So first of all, again, we have studied that what is quotient space. Now we study in details. Okay. Now let X be a topological space. Okay, now how to generate a quotient space. Okay, now how to give a quotient map and how to generate a quotient space. Now let X bar be a partition. Uh, it should better to say that partition, shall I say, or collection of partition, shall I say? Partition is the correct sentence. Okay. Be a partition of X whose union is X itself. Okay. Now define a map P from X to X bar by P of X going to that one. Now what is this? Now this is the set of the partition containing X. Okay. Now then obviously P is a surjective function. Now the quotient topology now given X bar the quotient topology given by P. Now then x bar with the topology is called the quotient space. Okay. Now you confused a little bit, right? What is the definition? Actually क्या करना है, तुम्हारे पास एक x है, x है सेट, तो हम क्या करेंगे कि x के जो एलिमेंट्स है ना उससे हम बहुत से सबसेट्स बनाएंगे। हम अब हम ऐसे एक सबसेट्स का पार्टीशन लेंगे जिसका अगर यूनियन करेंगे तो फिर x ही हो जाएगा, ठीक है। देन तो व्हाट इज x? x इज a set. Now what is x bar? X bar is a collection of disjoint subsets of x, ठीक है। और मैप हम डिफाइन करो सर्जेक्टिव मैप so that x going to the set, which set? The set containing x. And then हम topology, since it is a surjective function and we have seen that every surjective function generates a unique quotient topology, तो हम उसको unique quotient topology दे देंगे and then उसके हम बोलेंगे quotient space. Okay, example लेते हैं। मान लो कि x is तुम्हारा closed interval 0 1. Okay. Now what is x tilde? X bar. X bar हमने ऐसे डिसाइड किया all the collections, ठीक है। What is this? Now this is all the x such that 0 less than equal to x less than equal to 1. So this is the notation. Now what is x bar? Suppose x bar है तुम्हारा 0 1 a वाला सेट से and all the singleton sets x होगा where 0 less than x less than 1. और हम ऐसे लिख सकते हैं ऐसा singleton sets का collection with one only two elements. Is that clear? The sets x और x bar दोनों क्लियर है, दो सेट्स समझ में आ रहा है? Yes or no?
Yes.
Okay. Now ये बताओ then what is my p? P of 0. So p is the quotient map and the way we are defining x to x bar. Now what is p0?
0 1 set.
0 1 set. Now what is p1?
That is also single set 0 1.
That's mean p0 equal to p1, right? Okay. Now what is p of x for 0 less than x less than 1? What is that set? That one?
Singleton x.
That is singleton x. Okay, fine. Then हम टोपोलॉजी दे सकते हैं, ये वाले एक सेट से ये भी एक सेट से हम इसमें भी टोपोलॉजी देंगे। ओके ऐसे हम टोपोलॉजी दे रहे हैं कि देखो अभी अभी ज्योमेट्रिकली सोचो, you have a closed interval 0 1, okay, and in the open interval this 0 1 that x going to singleton x. So इसके जो ओपन सेट्स होगा पहले और p इनवर्स जो था ऑलमोस्ट वो सेम ही है। समझ रहे हो कि 0 लेस देन x लेस देन 1। ओके तो सपोज मान लो कि हमने एक ऐसा लिया था कि x माइनस एप्सिलॉन x प्लस एप्सिलॉन, एक एप्सिलॉन नेबरहुड लिया था ओपन सेट्स उसमें, तो ये जो सिंगलटन एक्स होगा containing x, तो बताओ अभी जो सिंगलटन एक्स है इसके ओपन सेट कैसा देखने में होगा देन?
सेम ही होगा।
हाँ सेम ही होगा, बट हम ऑर्डर नहीं बोल सकते क्योंकि हमें तो ये नहीं पता है कि इसमें ऑर्डर है कि नहीं, है ना। बट हमें पता है कि एक एप्सिलॉन नेबरहुड होगा। हाँ ठीक है। ओके, तो अभी तुम कोई आइडिया बोल सकते हो कि ये जो एक्स बार है एक टॉपोलॉजिकली एक्चुअली एक्स बार क्या है? ये एक्चुअली पता होना चाहिए कि टॉपोलॉजिकली एक्स बार क्या है। व्हाट इज द सेट, व्हाट इज द टॉपोलॉजिकल स्पेस एक्स बार?
Sir,
Circle.
usual topology on 0,1 open interval, like
ओके, 0,1 ओपन इंटरवल।
so usual topology on open interval 0,1.
हाँ बट ओपन इंटरवल 0,1 तो ठीक है, तो फिर मतलब x के जो ओपन इंटरवल 0,1 होगा और x बार के जो ओपन इंटरवल 0,1 होगा दोनों सेम है, ठीक है। बट इसमें तो और एक एलिमेंट है ना जो 0 और 1 एक पॉइंट पे जा रहा है।
सर अगर हम इसको ऐसे फोल्ड करके सर्कल बना दे तो ये वो नहीं बनेगा?
मैं वही पूछ रहा हूँ, वो क्या तुम्हें विजुअलाइजेशन हो रहा है कि दिस वन x इज दिस एंड x बार इज सर्कल, दिस इज माय p0 इक्वल टू p1।
यस सर।
क्योंकि अगर तुम कोई भी एक शेप पॉइंट लोगे यहाँ पे, इसका बाद तुम ओपन सेट देखोगे, ए ओपन सेट, तो कोई भी ऐसे ओपन सेट पॉइंट होगा इसका ओपन सेट इस टाइप का ही देखने में होगा, ठीक है। तो क्वोशिएंट टोपोलॉजी ऐसा है कि ये तुम अगर लिखने की कोशिश करोगे डिटेल्स में तो बहुत ही कॉम्प्लिकेटेड हो जाएगा, तो ये तुम पिक्टोरियली सॉल्व कर सकते हो, दिस इज अलाउड, ठीक है दिस। और अगर तुम 0,1 में ओपन सेट देखोगे इस पॉइंट में, देन इस टाइप का होगा ओपन सेट्स एंड ओ इस टाइप का ओपन सेट्स होगा। तो कोई भी तुम ओपन सेट लो इस पॉइंट से, जो P0 इक्वल टू P1 जो है ना, यहाँ से कोई भी एक पॉइंट ए पॉइंट लो, इसका ओपन से इसको देखो ए इंटरवल है, इस इंटरवल के इनवर्स इमेज क्या है, ए इंटरवल है, बट दिस इज ओपन, राइट। नाउ दिस यूनियन दिस इज ओपन, so therefore this is also open. And similarly if you take this one, if you take inverse image of this one, this, now this is open, so this is also open, so these are the open sets. But if you take this one and if you take only these open sets, now this is also open, but what is the image of this one? No, this one. Now is this open in circle? Now this is open in this interval. Now is this open in circle?
नो सर।
No, this is not open in circle. But then फिर ये क्यों क्वोशिएंट टोपोलॉजी हो रहा है? ओपन सेट तो ओपन सेट में नहीं जा रहा है, देन क्वोशिएंट टोपोलॉजी क्यों हो रहा है?
क्लोज्ड होगा सर फिर तो।
नहीं, क्लोज्ड भी नहीं होगा, ये तो क्लोज सेट है नहीं, क्योंकि ये ओपन सेट तो है बट सैचुरेटेड ओपन सेट नहीं। क्योंकि ये जो पॉइंट है इस ये पॉइंट इसका इनवर्स इमेज होगा दिस पॉइंट एंड दिस पॉइंट, तो ये सैचुरेटेड ओपन सेट्स है नहीं। ठीक है, ये तुम्हें समझना है। ये एग्जांपल क्लियर हुआ है? देन थोड़ा सा कॉम्प्लिकेटेड एग्जांपल में जाता हूँ।
सर
फाइन।
So,
हाँ
like if we have like two topological spaces x and y, and we are having a quotient map from x to y, such that y having some unique. We know that y will have a unique quotient topology. So can we say there does exist some another function q such that the quotient topology generated on y will be same as from the p?
क्वेश्चन ठीक ठाक क्लियर नहीं हुआ, दोबारा बता सकते हो कि दो फंक्शन रहेगा P1 एंड P2।
Like sir, हमने like y x to y एक मैप जा रहा है p, and then उस मैप से हमने like we generated a quotient topology on y.
हाँ
So like can we define a different function different from p function p, like again we define a quotient topology on y with respect to another function q, such that both of the topologies will be the same, quotient topologies on y will be the same.
आई गॉट योर पॉइंट। लगता है कि ट्रू नहीं होगा। क्योंकि तुम्हारा ए मतलब अगर मान लो कि P1 और P2 दो क्वेश्चन दो मैप्स है सर्जेक्टिव मैप, बोथ आर डिफरेंट, देन तुम्हें बस एक क्या है कि एक ओपन से जनरेट करना है कि इसमें ओपन होगा बट उसमें ओपन नहीं होगा। दैट इज अ गुड क्वेश्चन। सोचो ये, मुझे लगता है कि नहीं होगा।
Okay, sir.
दैट इज अ गुड वेरी गुड क्वेश्चन। Okay, next we take another example. See, you have to visualize what will be the quotient space. That is the main trick here. Say x is this, x square plus y square less than or equal to 1. That's mean closed disk. Okay, and say x bar is the collection. हम all the xy लेंगे singleton, where x square plus y square that is less than 1. Okay, fine, with 0, including 0, and these are the singleton, but a collection ले लेंगे where x square plus y square equal to 1. This. Okay, that's mean हम एक क्वेश्चन टोपोलॉजी देंगे यहाँ से और एक स्पेस में, जो ये जो इंटीरियर है ना, ये इंटीरियर वाला डी, यहाँ पे इंटीरियर वाला डी ही होगा, बट ये जो बाउंड्री वाला सर्कल है ये एक पॉइंट होगा क्वेश्चन टोपोलॉजी में। सो दैट्स मीन यू कैन से दैट P, मान लो कि कोई भी एक इंटीरियर पॉइंट है तो वो तुम्हारा इंटीरियर पॉइंट होगा फॉर इंटीरियर पॉइंट एक्स वाई इन डी इन एक्स से, देन P एक्स वाई इक्वल टू दिस सिंगलटन सेट्स, मतलब इंटीरियर पॉइंट्स में सेम है। But for the boundary points, means for say 1 0, p of say 1 0 equal to p of 0 1. In fact, p of any cos 2 pi s comma sine 2 pi s for any element that is a single point. You can name this any. Say this is say some n, any point. To any boundary points actually goes to a single point. Okay, so you have a disk, interior goes to interior. Now, first of all, can you guess what will be the quotient space? Because here to prove this pictorially, you have to first uh, you have to guess the quotient space, and then you have to define the open sets pictorially.
Sphere type.
Right, so that will be a sphere. So that's mean this is your disk and this is your sphere. Okay, and this boundary actually say goes to this point, and this point say it is S, say this point. Now if you take any open set say containing this, then that open set will be this way. So this side and as well as in the back side. Okay. Now if you have any point here, any point, and then if you have any small neighborhood, then that neighborhood will be in here, suppose in this way. And if you have any small neighborhood there and with the back side, this, then that one will be your this kind of options.
ये स्फीयर होलो है ना सर?
हाँ होलो है
ठीक है.
this. तो ये तुम्हें दिखाना है कि ये ओपन सेट ऐसे ऐसे जा रहा है, तो ये क्वेश्चन स्पेस हो रहा है. तो ओपन सेट्स का प्री इमेज ओपन सेट्स एंड इमेज एंड ओपन मतलब हाँ एंड सैचुरेटेड ओपन सेट्स का प्री इमेज भी ओपन सेट्स. Okay, fine. Right. Now that those are very interesting. Now first x equal to say 0 1 product 0 1. That is the rectangle. Okay, this one. ठीक है, लेंथ में थोड़ा इधर उधर है, ठीक है, geometrically fine. Okay. Now what we are doing? Now first of all, say so x cross, this is my 0 cross 0. Okay, we do not have order topology, right? So we can write in form of this one as well. So 0 comma 0, 1 comma 0, 0 comma 1, 1 comma 1. Okay. Now suppose 0 cross y comma 1 cross y. It is same one. Now this one we identify, this one is pairwise same. 0 less than equal to y less than equal to 1. Okay, and for other points x y, that is singleton. For other points x y, we have the singleton x y. So this is your x and this is your x bar is a collection of this. So for these points we have only pair, and for the other points we have singleton. Now can you tell me what will be your x bar? What is the quotient space x bar?
So that
Cylinder.
will be like cylindrical.
Right. So that's when we are actually we are identifying this with this, this with this, the corresponding. So we can write in this way. We are identifying this edge in this direction with this. So we are getting a cylinder actually. So this is my x, and we are getting a cylinder. So this is my x bar. Right? Okay. Now say x equal to 0, 1, cross
सर
0, 1. Yes.
सर ये जो शीट है हमारे पास, जैसे हम जो रेक्टेंगल इसको इंक्लूड कर पा रहे हैं, इसको राइट साइड को रोल करेंगे ना, या अप से डाउन से अप करेंगे रोल, मीन सिलेंडर बनाने के लिए?
नहीं, सिलेंडर बनाने के लिए ए है ना हमारे पास, मुझे देख पा रहे हो?
यस सर।
हाँ, ए हम बस ऐसे ही रोल कर देंगे, बस हो गया।
गॉट इट सर।
ठीक है, सिलेंडर हो गया। ये कॉरेस्पॉन्डिंग पॉइंट ही बस आइडेंटिफाई हो गए। नाउ सपोज हम थोड़ा सा चेंज करेंगे यहाँ पे, तो 0, y के साथ हम क्या करेंगे, 1, -y। -y तो नहीं बोलेंगे, 1, 1 -y को आइडेंटिफाई करेंगे फॉर 0 लेस देन इक्वल टू y लेस देन इक्वल टू 1, एंड फॉर अदर पॉइंट्स we are writing only singletons. Now अब बताओ x बार क्या होगा?
सर एक ऊपर वाले डायरेक्शन में जाएगा, एक नीचे वाले डायरेक्शन में, और उसको मतलब मोबियस स्ट्रिप टाइप का बनेगा।
हाँ, मोबियस स्ट्रिप ही बनेगा। ठीक है, तो हाँ मेरे पास है ऑलरेडी। तो ए वाला है, तो हमें क्या करना है कि तुम अगर इसको एक बार ट्विस्ट कर दोगे, देन दोनों ही सेम डायरेक्शन में चला जाएगा, अप एंड देन दोनों को आइडेंटिफाई कर दो, देन ए बनेगा, है ना? दिस इज कॉल्ड मोबियस स्ट्रिप। तो इसको बोलेंगे हम मोबियस स्ट्रिप। Then x tilde is Mobius strip, or you can say that, sorry, Mobius bend। तुम उसको ड्रॉ भी कर सकते हो चाहो तो ऐसे जाके ये लोअर से आएगा एंड oops, sorry, तो एक ट्विस्ट होके एंड देन आइडेंटिफाई होगा। अब फिर से गड़बड़ कर दिया मैंने। नाउ ठीक है, फाइन। ओके, तो ये याद रखना कि क्या होता है एक्चुअली। सो ए यहाँ से जाएगा, देन यहाँ से वापस आएगा, देन यहाँ से जाएगा, देन वापस में इससे आएगा। ठीक है, तो 2 राउंड होके ए सेम पोजीशन में आता है, तो दैट इज मोबियस स्ट्रिप। फाइन। नाउ सिमिलर कंस्ट्रक्शन अगेन, x equal to 0 1 cross 0 1, and say this one is this form, say 0 y 1 y, ये आपस में सेट्स होगा, 0 लेस देन y लेस देन इक्वल टू 1, देन x0 होगा x1 where 0 less than x less than 1, तो 4 पॉइंट से 0 0 1 0 0 1 1 1, ये चारों सेम में जाएगा, एंड फॉर अदर पॉइंट्स इट इज सेम, where 0 less than x less than 1 and 0 less than y less than 1, this। नाउ बोल सकते हो कि ये क्या होगा, what will be the quotient space?
Tube like structure.
Right, tube. So why? So first we have this rectangle. Okay, now what we are, that is my 0 0 1 0, this is 1 1 0 1. So what we are doing, we are identifying this with this, then we will have cylinder, and this is by 1. Okay, and then what we will do by 2, we are identifying in this direction with in these directions, so that's mean this point with this points in this way, so by 2। एंड देखो तुम जब इसके साथ आइडेंटिफाई करोगे, मतलब मान लो कि इसके साथ जब इस एच को आइडेंटिफाई करोगे, देन दिस इक्वल टू दिस हो जाएगा एंड दिस इक्वल टू दिस हो जाएगा, राइट। नाउ अगेन जब तुम इसको और इसको आइडेंटिफाई करोगे, देन दिस इक्वल टू दिस हो जाएगा एंड दिस इक्वल टू दिस हो जाएगा, देन दिस जो 4 वर्टेक्स है ये एक्चुअली सिंगल वर्टेक्स हो जाएगा, and you will have this, so that's mean you will have a tube, and this tube, now suppose that is your point, this say goes to say P, now that is your point P, and now what is your this one, now that black one, say that is my black one, this is one circle, that black one, and this red one, that's mean this red one, is this circle. Okay. So now if you take any open sets here, this, now this open sets actually is some here, some open set, this, in this boundary. Okay. Now tell me if you have some open sets this, what will be the inverse image of this open sets? फर्स्ट ऑफ ऑल बताओ कितना कॉपी होगा इसका? ये जो P है ये तुम्हारा ये 4 पॉइंट्स में इनवर्स में जा रहा है, तो ये ऐसा होगा, इसका ऐसा ऐसा। तो ग्रीन वाला है 1 टाइप, ऑरेंज वाला है 1 टाइप ओपन सेट्स, एंड ब्लैक मान लो कि इस ब्लैक के ऊपर है, कंटेन करके जा रहा है ऐसा। मैंने ग्रीन वाला गलत बनाया, ऐसा आएगा। ओके अभी मान लो कि ब्लैक वाला जो ब्लैक इसमें है, देन ऐसा आएगा, यहाँ पे एक आधा आएगा, इस साइड में आधा आएगा। ठीक है, अब मान लो कि रेड के ऊपर है, ओनली रेड के ऊपर है, मतलब बैक साइड में है, ऐसे रेड के ऊपर ओनली, देन ए सॉरी, देन यहाँ पे आएगा और यहाँ पे आएगा। तो दीज आर द ऑल टाइप्स ऑफ ओपन सेट्स। ओके now मान लो कि दिस सर्कल है, दिस आइडेंटिफाई हो रहा है ना, ये दोनों तो आइडेंटिफाई हो रहा है, आइडेंटिफाई होकर एक सर्कल बन रहा है। मान लो कि ये तुम्हारा ये सर्कल, दिस, तो ए पॉइंट जो है 0 0 1 0 1 1 0 1, ये जो पॉइंट्स है ये चारों पॉइंट्स का इमेज है P हो रहा है। सो दिस इज एंड दिस। ठीक है, और रेड से ऐसे जा रहा है वर्टिकली ऐसे, तो ये भी वर्टिकली सर्कल बनाएगा, और बैक साइड से आ रहा है। ठीक है, दिस। तो अभी मान लो कि ये ब्लैक कलर के ऊपर बिल्कुल ऐसे करके एक ओपन सेट बन रहा है ऐसे, तो ये ओपन सेट क्या होगा, इस टाइप का ओपन सेट होगा, 4 कॉपीज। तो इस ओपन सेट का इनवर्स इमेज दिस ओपन सेट्स। अभी मान लो कि कोई ओपन सेट ऐसे बन रहा है, मतलब ओनली टोरस के इंटीरियर के ऊपर, कोई भी जो सर्कल्स है वो सर्कल्स के ऊपर नहीं, ऐसे बन रहा है। देन कोई भी एक पॉइंट होगा यहाँ पे, उसके ऊपर ऐसे ही बनेगा। ये 2 पॉसिबिलिटीज है ना। और एक पॉसिबिलिटीज है, मान लो कि ये जो ब्लैक सर्कल्स है इसके अंदर जा रहा है ओनली, और रेड सर्कल को टच नहीं कर रहा है। देन यहाँ पे कोई भी पॉइंट होगा ऐसे ऐसे, तो ऐसे ऐसे ओपन सेट्स बनेगा। और मानो कि इस ओनली रेड के ऊपर एक सर्कल है ओपन सेट से, देन इसका मतलब कोई भी एक पॉइंट्स तो ऐसे ऐसे होगा, तो ऐसे ऐसे ओपन सेट्स। तो इसका मतलब है कोई भी ओपन सेट्स यहाँ पे ले लो क्वोशिएंट स्पेस में, उसका इनवर्स इमेज भी ओपन ही हो रहा है। एंड इसमें भी कोई भी एक्स में भी कोई भी सैचुरेटेड ओपन सेट ले लोगे तो उसके इमेज भी एक ओपन सेट से होगा. सो दिस इज ए क्वोशिएंट मैप. ठीक है, समझ में आया है? तो एक्चुअली जो क्वेश्चन स्पेस है ना, इसके ऊपर भी हम काम करेंगे. मान लो कि कोई भी एक टोपोलॉजिकल स्पेस है, उसके साथ और एक आइडेंटिफाई करेंगे तो क्या होगा, तो हम ये सब कुछ भी दिखेंगे. तो राइट, तो हम ऐसे पिक्चर सब ऑलवेज ड्रॉ नहीं करेंगे, हम ऐसे ही लिखेंगे इसको. So torus means, so this identify with this and this identify with this. So this is equivalent to saying that that is torus. So इसका मतलब A जिसके साथ आइडेंटिफाई हो रहा है, फर्स्ट ऑफ ऑल जिसके साथ this, then we will get a cylinder, and then so first if we do this, then we will have a cylinder, and then we will get torus. So cylinder means ये जो दो था, ये दो मिल के सिंगल हो गया, एंड देन अब जब आइडेंटिफाई फिर से करोगे, ये सिंगल वाला था और ये डबल वाला था, बस हो गया. तो इसमें और एक चीज इंपॉर्टेंट है, सब कुछ हमने एक्चुअली कर लिया ये वाला. तो और एक हम कर सकते हैं कि पहले हम सिलेंडर बनाएंगे, देन ऐसे ऐसे आइडेंटिफाई नहीं करेंगे, इसके रिवर्स डायरेक्शन में आइडेंटिफाई करेंगे. इसका मतलब x इक्वल टू 0 1 क्रॉस 0 1 and x bar is a collection of x cross 0, say x cross 1, and say this one is like a Mobius strip, that is 0 comma y is 1 comma 1 minus y. So 0 less than y less than 1. Now trivially same, we have 4 points, and remaining points x y. तो इसके मतलब पहले हम okay, now x cross 0, x cross 1, so this, okay, so this is, and this is double 1. now in this direction के साथ हम इस direction में आइडेंटिफाई करेंगे, सबसे ट्विस्ट करके. तो तुम इसको ऐसे मान के चल सकते हो कि फर्स्ट वी विल गेट ए सिलेंडर, this, but the problem is that whenever you are adding this one, we are identifying with here this, that is the reverse direction. तो इसको ना, इसको ये जो आइडेंटिफाई होगा, इसको हम ना 3 डायमेंशन में देख नहीं सकते, तो एक्चुअली ये 4 डायमेंशन में एक फिगर होगा. तो ऐसे जाएगा, तो एक एक्चुअली अंदर आएगा, बट एक्चुअली अंदर आएगा नहीं, 4 डायमेंशन ऑब्जेक्ट से, देन ऐसा हो जाएगा. तो इसको बोलते हैं क्लीन बोतल. Okay, so we are done for today. So these are very actually important because that is also very topological thing, and there will be definitely few questions from here, and we will have one assignment on the problems from this quotient space only. So you have to solve all of those problems, but that is not for the quiz, but that is only for the minor. Okay, so any questions?
So, sir, if we like these corner points, if we include in the other two ones, so we don't have a quotient space or something like a punctured type of figures we will get.
Repeat again.
Like say we are having corner point 0, 0, 1, 0, 0, 1 and 1, 1. If we include two of the points in the first one and other two in the second one, so what will happen basically?
Right. But first of all, you have to see that can we do that or not, because this does not come this comes actually automatically, because whenever we are identifying, as I told you here, when we are identifying this with this, okay, forget about this one, it is a little bit complicated. Right, suppose when we have when we had cylinder, when we identify this with this, then 0 1 and 1 1 and 0 0 and 1 0 both are identified. That is pairwise identified, these two in Torah in the this one. And then when we do that torus, and when we identify the black one, then also see when we identify the red one, then 0 1 and 1 1 was identified, and when we put that black one, then 0 1 and 0 0 identified, and 1 1 and 1 0 identified. So these 4 points comes actually automatically. And if you want to do that pairwise distinct, then I think there will be a problem here. But of course, you can make a puncture in the sense that not in the quotient space, but here you can start with a punctured plane, and then you can do the same thing for a torus. Then you will get a punctured torus. But if you want to identify only pointwise, will it be a punctured? No, I don't think it will be a punctured one. It will not be a punctured one. It can be some pinched kind of thing.
Okay, sir.
So for this points comes actually automatically here.
Sir, sir, in this we are not giving the exact quotient space. I mean to say.
No. Exact quotient space we are giving here as well, na. So we have set X, and this is your X bar, this sets, and we are mapping. For an example, whenever we have say 1 0, 1 0 goes to this third set. Whenever you have say half comma 0, it going to the first space, a first point, this one. We are giving actually. What do you mean by this figure? That's mean whenever you have these points and this one, both are actually homeomorphic. If we give a topology on X bar as a abstract set, and then those topology will be homeomorphic to the induced topology on this clean bottle. And similarly here, when we so what is your X bar? X bar is just a set, right? And you can give a topology by the quotient map. Then you will have a topological space. Now that topological space is actually homeomorphic to torus, this one. So for an example, as I told you that these points are this P, right? And the points on this black line, that is in the item 2, it is the points in this black circle here. and here if the points in the red first item, the red item, it is the circle on this one in this way. So we are actually giving the exact topological space only.
Sir, in the last example, what will happen if we reverse both the directions?
Now think that one. Think that one. If you reverse both the direction, then what you will get? So this is also reverse, this is also reverse. You try to think that. That is a good one. So that is actually, that will be available in the assignment problem. So you have all possible directions and then what space you will get, all of this kind of thing.
Okay, sir.
Now suppose you have here, it is also suppose, okay, I am giving you the answer. Now suppose this is also reverse. So that's mean the you can think it is only one. For an example, say sorry. So this, and this with this. You are saying that, right?
Yes, sir.
Now say that now if you can combine this and this, you can combine these two. That's mean you can choose this point and these points. See this one and this one are same. So therefore you can think it is of a circular region, this one, and where this and this. So these two are same identification. And this is called RP2. Now this is very complicated to see. Though the clean bottle is little bit visible, but this RP2 it is not visible at all. That's mean you have a disk and you are identifying these points with these points. You are identifying all the antipodal points. You have a disk and you are identifying x with minus x at the boundary. So that space cannot be visible. But you cannot also think about that. So what is that? You have to just, you can search in the internet, YouTube. So Klein bottle, torus, projective space, these three. Projective space, torus, and Klein bottle. Now you will see some interesting answers. Okay, sorry. Oh, there is no figure, but okay, anyway, I will send you. Okay, okay, then we can stop today. It is already 3:30.